Welcome to another tutorial on the Pythagorean relationship. In this tutorial, I'd like to explore how you can use this relationship to find unknown side lengths in a right triangle. Let's review quickly. Here we have a right triangle, and we know that because over here this little square tells us this is a 90-degree angle, and all right triangles have a 90-degree angle. This is side A or leg A. This is side B. A and B are the two shorter sides of a right triangle. This is side C, the longest side in a right triangle, which we call the hypotenuse. If we move over to this diagram here we've drawn a square off of each side of a right triangle. We call this square A because this is side A. And to find an area of a square, we would do side times side, which is A times A to get A squared. The area of square B is B squared, and the area of square C is C squared. In this relationship, this Pythagorean relationship, if you take the area of square A and add it to the area of square B, you always get the area of square C. And we can use this to find unknown side lengths. In this right triangle, we've been given two pieces of information. We've been given the side length of A, which is 6 centimeters, and we've been given the side length of B, which is 10 centimeters. What we're trying to find out is how long is side C. We also haven't been given any areas for this triangle, so let's begin by drawing a square off of each side of this right triangle. So I am drawing these squares freehand, so they won't be perfect, but that's okay. So we'll draw a square off of each side of this right triangle. And then the next step is going to be to find the area of each square. So for this one, it's going to be 6 times 6 because we have side lengths of 6. So that makes this area, the area of square A is going to be 36 centimeters squared. And for side B, it's going to be 10 times 10, which is going to give us 100 centimeters squared. Now, according to our relationship, which we've been talking about here, according to this relationship, I'm just going to bring up the equation here. So here's our equation. This is the relationship. So according to this relationship, if we take the area of square A and we add it to the area of square B, we should get the area of square C, which in fact will work. So what we're going to do is we're going to add 36 from 36 centimeters squared as the area of square A. We're going to add it to the area of square B, and we're going to get an area of 136 centimeters squared. But we're not finished yet because we are actually being asked to find out how long is side C. Not the area of square C, but one side length of square C. Let's drag square C out here all by itself and take a look at it. So what in fact we're being asked to do is we're being asked to find out how long is each side of square C if it has an area of 136 centimeters squared, which is the same thing as saying what number multiplies by itself to make 136, because we know that side times side is the area of a square. Another way of thinking about this is to find the square root of 136. This means what number multiplies by itself to make 136. So we could say that the square root of 136 is 11.66 centimeters. 11.66 is rounded to the 100th place. It's actually a longer decimal, but we'll round to the 100th place value. So this then means that each side length of this square is 11.66 centimeters. Therefore, we could say if every side of this square C is 11.66 centimeters, we could say that the hypotenuse or side C of this right triangle is 11.66 centimeters. At this point, I'd like you to pause the tutorial and try to find the length of side C and then compare your answer with mine. I'm going to begin by drawing a square off of each side like I have shown you before. So I'm going to draw a square off of side B and side A and side C. And once I've done that, I can then try to find the area of each square. So for square A, I'm going to do 12 times 12. And 12 times 12 equals 144 centimeters squared. For side B, I'm going to do 11 times 11, which is going to give me an area of 121 centimeters squared. And if I add the area of square A to the area of square B, so 144 plus 121, I'm going to get an area of 265 centimeters squared for square C. And I need to go one step further because I need to find out how long is each side of square C. So I'm going to take the square root of 265. What number multiplies by itself to make 265? And I'm going to get an answer of 16.29 centimeters. 16.29 is rounded to the hundredth place value. So we'd say side C is 16.29 centimeters. One more question to try. This time you've been given the length of side B, which is 7 centimeters. You've been given the length of side C, which is 16 centimeters. You were trying to find the length of side A. So pause the tutorial, try to find the side length of A, then compare your answer with mine. As always, I'm going to begin by drawing a square off of each side. So let's draw a square off of side B. We'll draw a square off of side C, and we'll draw a square off of side A. And then I'm going to find the areas as I always do. So the area of square B is going to be 7 times 7, which is going to give us an area of 49 centimeters squared. And for square C, I'm going to do 16 times 16, which is going to give us an area of 256 centimeters squared. Now we have to do something a little different here than we have in the previous couple questions, because you don't have A. So I can't do A, area of A, and the area of B. What I have to think of is what number adds to 49. So 49 plus what number, which would be this one, equals 256. Or another way of thinking about that is just to subtract 49 from 256. So if I do 256 and I subtract 49, I'm going to get 207. So then I know the area of square A is 207 centimeters squared. To find the side length of square A, I'm going to take the square root of 207, and the square root of 207 is 14.39 centimeters. Side A is 14.39 centimeters.